Hi, welcome to part 12 of the video series about laws of motion. In the previous one, we have learned how to calculate the normal force applied on an object in a lift. In this video, we are going to learn about what the friction force is. Then we will classify friction forces as static and kinetic friction force. At the end of the video, we will learn about the coefficient of friction. Let's imagine that there is an object on a smooth surface. With our naked eyes, the surface seems very smooth. But zooming in by using a microscope will tell us a completely different story. The surface which we were considering as smooth actually has a lot of roughness in it. While trying to move the object, this roughness will cause all kinds of problems. It will result in a force which opposes the motion of an object. This force is known as the force of friction. The frictional force is the force that opposes the motion of an object and acts parallel to the surface the object is in contact with. The amount of friction between two surfaces depends on two factors: the kind of surfaces and the force pressing the surfaces together, in other words, normal force. Let's imagine a situation where we are applying a small force to push a fridge, but fridge is too heavy and remains at rest. We know from the first law of motion that if an object is at rest, the net force applied on it is equal to 0, which means there is another force which is opposing the force we have applied and nullifying its effect. This opposing force is the force of friction. For this specific case, friction force which has been applied on a stationary object is also known as static friction force. Static friction is a type of friction force that acts on a body when there is no relative motion between the object and the surface. If we come back to net force is equal to 0 equation and proceed from this point onwards, there are two forces applied on this object. Applied force, which is to the right, has positive value, and the friction force, which is opposing the motion, is going to have a negative value. Applied force minus friction force is equal to 0. As a result, we can see that the magnitude of the friction force is equal to the magnitude of the applied force. Let's try to plot this information on a graph. This is friction force versus applied force graph. It is going to display the relation between these two. According to the equation we wrote, these two forces are equal. If there is no force applied on the object, then there is no friction as well. Then we start to apply a force, and immediately the object will experience a friction force as well, and the value of friction force will increase as the value of applied force increases. Of course, the fridge cannot resist the increase in the force forever. At one point, it will give up and we will be able to move it. This is the point where we manage to overcome the maximum value of static friction force, which means that now we can split the graph on the screen into two parts. The part where the object is at rest and experiences a static friction force, and the part where it has overcame static friction force and starts to move. We have managed to move the object. Now let's learn about friction force applied on this object while it is moving. On the image on the screen, we finally managed to move the object, and now it has a velocity which is greater than 0. Friction force applied on this object is called a kinetic friction force. It is type of a friction force that opposes the relative motion between objects in contact. Let's bring back the graph and the diagram from the previous slide. This time we only consider the part where the object is already moving. There is an applied force trying to pull it to the right and friction force opposing the motion. As we have already passed the maximum amount of friction force, it cannot increase anymore. but we can still increase the applied force. While the applied force increases, friction force remains same. We get a complete graph representing the relation between the friction force and applied force. Till this point, the object is at rest, and after this point, it is moving. Before this point, the friction force is static and equal to the applied force. After this point, the friction force is kinetic and its value is constant. Everything seems okay, but why there is this gap in the graph? Did we draw it wrong, or is there something going on? The graph is correct. While explaining the friction force, we have mentioned that the reason of friction is the roughness between two surfaces. The story is true, but not complete. Another reason of friction is the attraction force between the atoms or molecules on the surfaces of two objects. So, while the object is at rest, these molecules or atoms start to know each other better and attraction between them increases. Thus, if we want to move the object, we have to overcome not only the roughness in the surface, but also this attraction force, this bond between the atoms or molecules. Afterwards, we will not have this attraction problem, so the friction force will become slightly smaller. In the last part of this video, we are going to learn how to calculate the friction force. Let's imagine this rough surface. It is rough, but there can be even rougher surface, like the one on the right side. Of course, it seems that the friction force on the right side will be greater than the one on the left due to much greater roughness. To represent how rough the surface is, we use the Greek symbol mu. So the roughness on the left side can be represented by mu1 and the one on the right by mu2. Name given to mu in physics is the coefficient of friction. It is a value that is experimentally determined and depends on the two materials interacting. In the first part of this video, we have mentioned that the friction force depends on two factors: the kinds of the surfaces, which is represented by mu, and the force pressing the surface together, the normal force. Combining these two factors will give us a formula to calculate the force of friction. Force of friction is equal to the product of coefficient of friction and the normal force. There were two types of friction force, so we have to adjust the formula to both of them. The first one is the static friction force. We will use this formula to calculate only the maximum value of static friction force, as otherwise it is always equal to the applied force. The equation will become as maximum static friction force is equal to coefficient of static friction times normal force. Once we overcome the static friction force, there is kinetic friction force, which can be calculated as coefficient of kinetic friction times the normal force. As maximum static friction force is slightly greater than the kinetic friction force, so are coefficients. Coefficient of static friction is slightly greater than the coefficient of kinetic friction. There was a lot of theory in this video. We have learned about what the friction force is. Then we had classified friction force as static and kinetic one. And at the end of the video, we have learned about the coefficient of friction. In the next video, we are going to apply this theory to solve some examples related to the friction. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.